So the objective here is going to be to demonstrate what a limit is. And so we're going to do that using a brief numerical example. Let's say that we're given a function. So we are given a function that y is equal to 2x minus 1. And we are going to be asked what is the value of y as x approaches 3. So in other words, if we have this function y, as x gets closer and closer to 3, what is the corresponding value of y? And so one way to think about this is to build a table. So we're going to build a table here. Here's x, and then here's our function y. And we can also call y, we can also call this f of x. And so if we're trying to get x closer and closer to 3, I might start off with a value of x of 2.9, and then I'll get a little bit closer to 3, so maybe 2.99. And then I'll get a little bit closer to 3, maybe 2.999. And then I'll get really, really close to 3, so maybe 2.9999. And so what I want to do is I want to calculate, well, what is the value of y as x gets closer and closer to this value 3. And so what I'm going to do is I'm going to plug in this 2.9 into our original function here, and I'll calculate what y is. And in this case, we find that y is equal to 4.8. How about this next one? I'm going to take 2.99, plug that in for our value of x, and I find that y is equal to 4.98. And so I'll do the same thing for each of these values, so 2.999, and I'll plug that in, and I'll get y is equal to 4.998. And then I'll do the same thing for this last value, and I'll find that y is equal to 4.9998. And so we can see that as x approaches 3 from the left, the values of y seem to be approaching this value of 5. And so the way we might describe that is as x approaches 3, y is approaching 5. But we can also do this for the other side. So let's go ahead and do that. So we have 3 here. And I'm going to draw the same table here, x and y. And again, of course, y, you could call this f of x if you wanted to, just a quick name change there. And let's get closer and closer to 3, but from the other side. So we might start with a value like 3.1, and then we'll get a little bit closer, maybe 3.01. And then we'll get a little bit closer, maybe 3.001. And then we'll get really, really close to 3, so 3.0001. And again, our objective is to determine as x gets closer and closer to 3, what does y get close to? And so we'll do the same thing as we did last time. We'll take our 3.1, we'll plug that into our original equation, and we'll find that y is equal to 5.2. And we'll do the same thing for 3.01. You guys are probably getting the hang of this now. If you plug x is equal to 3.1 into the equation, you'll get 5.02. If you plug 3.001 into the equation, you'll get 5.002. And if you plug 3.0001 into our expression for y, we get y is equal to 5.0002. And so it seems, and we can write this out, as x approaches 3 from the right, because we're approaching from the right this time, y is approaching 5. So if I were to show what that looks like, I'm just going to scroll down here for a second. And if I were to graph this function that we have, and this is going to be the function y is equal to 2x minus 1. Here, let's say this is 2. And this right here is going to be our function. This right here is going to be y is equal to 2x minus 1. here is our point where x is equal to 3. Here's x is equal to 3. And as x approaches 3, y is approaching this value of 5. And so what this looks like is as x gets closer and closer to 3, the value of y seems to be approaching 5. And as x approaches 3 from the right-hand side, the value of y seems to be approaching 5 as well. And so what we might write is that the limit as x approaches 3 of f of x is 5. Or, written a different way, the limit as x approaches 3 of 2x minus 1 is equal to 5.